So these are available operators that you can overload in your C++ code. And some of these operators are unary operators, some of them are binary operators, and there is obviously a broad range. Pretty much almost all of the operators can be overloaded. Some special notes. All of the assignments, including arithmetic assignments, just like those that we had in our example, for instance, plus equals, and the example of it was that this is the concatenation, and this is sort of like concatenation in place. We take the value of hello, we combine it with another string, and we store it back in the hello object. So we update this object with the concatenated version. So this is called like arithmetic assignment technically, and this is assignment operator right here. So all versions of assignments, including arithmetic versions of them, have to be implemented as members. Subscript operator, function call operator, and also pointer to member also have to be implemented as members because they require lvalue. So lvalue is a left-hand side. The idea, the name is derived from the left-hand side of the assignment, and we're going to discuss it when we talk about lvalue specifically. So the operators that are generated by the compiler for free, you don't have to write them. The assignment operator, remember, just does bitwise copy. Address of course, will return the location of your object in memory. The comma operator or sequencing operator is also provided for free, so that you can basically sequence your expressions that resolve to the type of your class when you program your expressions. The following operators cannot be overloaded. So one of them is this scope resolution operator, right? So the scope resolution operator cannot be overloaded. You just cannot redefine what this does, because this is absolutely fundamental to just compiler understanding or what we're trying to do with members of our classes and namespaces. Okay, so there's also member selector that cannot be overloaded, and member selection through pointer to member cannot also be overloaded. So these are not available for overloading. Non-member operators must take at least one user-defined type. So what it means is that you cannot just overload an operator like this. You cannot just say operator equals and redefine it for two integers, right? So if you say int, int, this is an error. Compiler will not allow overloading operators for fundamental data types. It means that it's always whenever the operator overloading is involved, one of the objects have to be a user-defined type. Okay, so that's the restriction that prevents us from overloading operators for fundamental data types when they're involved. So let's talk a little bit about lvalue and rvalue as well. Let's just resize this so it fits on one screen right here. So left-hand side value. So let's just the idea is coming from the fact that lvalue is something that may look like this, equals a right value. Okay, so if you look at the statement like this, of course this is assignment, of course this refers to something, and this also refers to something. So this is where the lvalue term is deriving itself, as well as the right-hand side value, with respect to the assignment, which is a typical situation where lvalue versus right-hand side value could be part of the discussion. So lvalue is an object that refers to a region of storage in memory, right? So we're thinking that this has to be something that could be representing a region in memory, like real physical memory. And typically it can be both examined and stored into. Okay, so at some point this thing in memory accepts new data. However, the lvalue, or left-hand side value here, does not necessarily permit modification of the object that it designates. Sometimes it's okay, sometimes it's not okay. So there are situations where there's some other subtle variances in this. So lvalue can be modifiable and non-modifiable, but still considered to be an lvalue. Just I think this is primarily this, a region of storage in memory. So that defines what lvalue is. Function call that returns a reference to something is an lvalue, right? So right here we could make a function call, and if it returns a reference to another object in memory, it could be used on the left-hand side of the assignment right here. So that would be, so the function call itself becomes a representation of an lvalue because it returns reference to an lvalue. Certain operators, and that's the reason why we're discussing this technicality right here, that certain operators require lvalues. So taking address of, unary address of operator requires that the operand has to be an lvalue. In other words, it just violates the idea of an address, conceptually taking address of an object. For instance, to give you an example, if you have a constant 2, right, you cannot overload address of, because this is a constant, so it's definitely not an lvalue. It could be used by the compiler only at the compile time, and you're trying to take address of this constant that may be used only during compile time. So this is not allowed. Okay, and so that's an example of the restriction with respect to lvalues when we're talking about address of. Increments and decrements, of course, they're sort of like take something and they update with prefix or postfix forms, and that also requires an lvalue. So it's not just assignment. There are other sort of deriving from here other situations where the restriction by the compiler is that something has to be an lvalue. All of the assignments, right? All of the assignments, the plain assignment and all arithmetic assignments have to be lvalues. Now the term rvalue, the right-hand side value, refers to a data value that is stored in some address in memory, but it can basically never have a new value assigned to it. So lvalue most of the time allows modification, but it's not always required by the context in which it's used. But a constant literal like this, of course, it's stored in memory. So, but it can only qualify itself as rvalue, and you can just kind of accept it, so that if I have my string, right? So I use these double quotes, and I have some sort of string. It can never be used like this, right? So it can never appear on the left-hand side of the assignment, because this is constant. It's just it just doesn't make sense, right? So this is wrong, and so that's why things like this can be considered right-hand side values only. So when necessary, L value can be converted to R value. So that's not a restriction, right? So basically think about normal variable like X. It can be used both as, Y equals X. So in this case, this L value is used as R value, but we can also say that X equals Z. Like this, right? So then it is used as L value. So the conversion implicitly are not restricted. And we discussed that the opposite is not possible already. So this is just this quick overview of things that sometimes appear during the discussion of operator overloading and other contexts, the left-hand side values and right-hand side values, and they're all deriving themselves from the idea of what happens during the assignment and other differences, some restrictions, and R values are more restricted and L values are less restricted in general.